just since this is a recording, just go over definitions. A polygon is a two-dimensional simple closed composed of line segment. Simple means the lines don't intersect. Closed means it starts and ends at the same place. On exam 2, the last question, that was the definition that you had to use, closed. It broke the definition for closed and simple. A quadrilateral, if you say a four-sided polygon, you're good. Parallelogram is, you can either say quadrilateral or four-sided polygon. It has two sets of parallel sides. Opposite is not necessarily necessary because it is just a four-sided figure. So if you have parallel sides, they have to be opposite. But if you put opposite in there, that's fine. And then you would say the opposite sides are congruent. Now, why would you have to state the opposite sides are congruent? We're in the class of quadrilaterals right here. Are there quadrilaterals that have congruent sides that are not opposite?
Kites.
Yeah, kites. So you have to say opposite because the minute if you just say two congruent sides, you've opened yourself up to both a kite and a parallelogram. So if you're in parallelograms, you have to be specific about them being opposite. And the angles are congruent. Okay, so let's go to the next one. You said rectangle? Mm-hmm. Okay, rectangle. All right, and what's the definition of a rectangle specifically?
Two sets of opposite.
Okay, two sets of, that's fine, sets of opposite.
Parallel sides.
Parallel sides. Parallel sides. What else?
It has 490-degree angles.
There's still something on the sides you need to include. Sides are...
No, not
yeah, they are. The opposite sides are congruent. Yeah, are congruent. Now, you could have, and you could have said that by stating what? It's parallelogram. Okay, so either one is correct. Parallelogram. I don't even know how to spell this. But there is a shortcut. If you know what a parallelogram is, it's part of the classification. So by stating that, you've just said the opposite sides are congruent and parallel. And you've also said what else have you said by saying it's parallelogram?
That is a quadrilateral with four sides.
Okay, you said it's a quadrilateral of four sides. What have you said about the angles?
Opposite angles are congruent.
Yeah, opposite angles are congruent because that's part of the parallelogram. So by saying it's a parallelogram, you automatically get all those definitions.
You can do that?
Yes, you can do that. Absolutely. Yeah, that's level 2 of the Van Hyle where you're using, you know how these things fit together. Level 1 would be where you have to do the properties individually because you don't realize rectangles are part of parallelograms. Does that make sense? Mm-hmm. So using those is actually showing that you know how these all connect together, which is a good thing. Absolutely. So you could have just said it's parallelogram, but there is an extra definition that goes beyond parallelograms for rectangles, and what is that?
The right angles.
Be more specific.
All angles are 90 degrees.
All angles, yeah, our right angles are 90 degrees. Does that make sense?
Mm-hmm. Do you have to put in the definition about the lines of symmetry?
No, that is not part of the definition of a rectangle. Now, it may be important if I ask you, it would be important if you were asked to find like the area of a rectangle and I gave you a diagonal. Because what I've just given you is a triangle. And knowing that the diagonal divides the area of a rectangle in half would be important. Does that make sense? Because I might give you, so if I gave you a rectangle and I cut a diagonal across it, right there you know it's a right triangle, right? So you got Pythagorean theorem. But knowing that that cuts it in half means if you found the area of that triangle, you can just double it for the area of the other one. Okay. So the fact that the diagonals bisect the, you know, and also knowing that they bisect too, if I gave you, let me see, if I gave you a picture, I'll draw on the board here real quick. Here, let me draw a rectangle here. If I gave you a picture like this, because this is a really good question. I mean, this is an excellent question. This is the kind of question I would ask. So let's just talk about it. Okay, so if I gave you a rectangle, right, and then I drew a line through it, like so. Hold on just a minute. Oh, you know what? This has got a fill in it, so it's not going to show. So let me click on the rectangle and make it no fill. There we go. Okay, so I've drawn a line through it. This would be a question, what's the area of the rectangle? And I give you the length of that diagonal 6. How would you find the area? What would you have to do? Would I have to give you one other thing? I'd have to give you one other piece, wouldn't I?
You can keep that 4 in there.
Yeah, let's leave the 4, because otherwise you can't do it. Now, if it was a square, you could, because the sides are the same, right? So I have a 4 on the side, a 6 on the diagonal. So what would you do to find the area of the rectangle?
4 squared plus b squared equals 6 squared.
Exactly. Yeah, you do 4 squared plus b squared equals 6 squared. Okay, let me go ahead and erase this. And I think, okay, so this is my right angle right here, because that's a rectangle. So that's one of the properties of a rectangle. And this is just elaborating on your question, Alexis, because that's an important question. So if you know rectangle is all right angles, you know half of it is a right triangle. So just tell me, you guys, you probably know this, but just tell me how you would start this. How would you find the area of a rectangle? What would you do?
Of that rectangle?
Mm-hmm.
Well,
With the information I'm giving you.
so you look at that again. So find out there's
Good. So how would you use the Pythagorean theorem? What would you do?
4 squared plus b squared.
Plus what?
B squared.
Good. Okay. And b, you're calling this one up here, equals,
6 squared.
okay? So 16 plus b squared equals 36, right? So then you get b squared equals what?
Yeah.
20, okay, and then you take the square root of 20 and you get, well, let's see, the square root of 16 is 4, the square root of 25 is 5, so it's going to be about 4.5 or something like that. So b would be approximately 4.5. That's a very rough guess, but something like that. And then, so let's just pretend like it is, okay, because just for sake of argument. So when you took the square root of 20, let's say you got 4.5. Then to find the area of the rectangle, it's easy now. You multiply 4.5 times 4. Okay, does that make sense? Mm-hmm. Okay, so the idea that these are right angles is important. Now, what I was starting to do a minute ago, and then we had to stop because it didn't work, was the idea that they bisect each other at right angles. That I don't know with this rectangle, but let me draw another rectangle and do something else. Let's say I have another rectangle, and I give you this information. Say this is 110, where this angle right here. Do you know the measure of all the other angles?
45. Oh, the other one's 110.
Right, okay. And this is 110, and again, remember I was asked for reasons? What's your reason for saying this one is also 110?
Because when you have
What are they called? Starts with a V.
vertical.
Vertical angles. Remember, vertical angles are across from each other at an intersection. So based on the fact that you've got vertical angles there, you have some more information. What else do you know?
Well, you know that on one of the lines, if you have an angle, I don't know how to explain this, like if you have a line and then if you have an angle on here, you know the line is 180. And if you know one of the angles, then you can subtract 180.
Okay, so you're saying this line right here, so this whole angle right here from here to here is 180?
Yeah.
Very good. So that means this little angle right here is what?
180 minus 110.
Which is 70. Good.
Is that called something like,
That's
I took this back in high school, like complementary angles or supplementary?
supplementary.
Okay.
Yeah, complementary is when the total angle measure is 90. Supplementary is when the total angle measure is a straight line, or 180. Exactly. So if you know this over here is 70, you automatically know why is this 70?
Vertical angles.
Because they're vertical angles. You're actually doing a proof that you would have done in high school. We're just not writing it out as paragraph form. Do you guys remember the 2-column proofs?
Yeah.
This is literally what you would do. And it's just, all this is deductive reasoning. It's using logic and inductive reasoning. What do you know? And based on what you know, what can you say? And based on what you said, why can you say it? And the reason that students do so bad in geometry is because they've never learned, it's called, in math we call it following your nose. You know, you take a step and then you look around and say, okay, where else could I go? And that's all it is. That's all math is just simply using properties and what you know to go further. And you always know what you need to. I wouldn't ask you a question you didn't know the information for. But you have to think through your list of things you know and use what you know. Okay, so we've got the inside angles all taken care of. Now how can we use that information for the rest of the angles in each of these? There's 4 triangles here. How could I use that information for this up here? Like for these guys. I need these. Well, how can I find that angle?
It was a 90-degree angle, but since you have a line there, it's cutting in half.
Do you know for sure that's cutting it? Does that look like a half angle?
No.
This one looks a little bit bigger than that one, all right? These aren't the same, so you can't use that, because you don't know that for sure. But there is something you know for sure. What do you know about triangles? Think about the properties of triangles.
All the inside angles add up to 180.
Okay, all the inside angles add up to 180. Is there something you know for sure about this triangle? Based on the fact that the diagonals bisect each other?
Well, you could look at the triangles from the bigger perspective and not all the little ones. Like, you could look at it as the first square, the first rectangle where you had it only split up in half.
Mm-hmm.
You could do the same thing, and then you know that that corner up there is 90. Oh wait, never mind. I'm looking at it wrong.
Okay.
Never mind.
All right, so that's a trail you ran down and didn't work, so you come back, okay. Just look at the one, look at this top one. Just look at this top one, the top one that has 110 degree. We know the angles bisect each other. What does it mean to bisect? The diagonals bisect each other. What does the word bisect mean? That would be intersect.
Okay.
Intersect means to meet in the middle. What does bisect mean?
Cut in half.
Cut in half, cut in half, bisect. You know? So if these are bisected, what can you say about the halves?
Would the other 2 angles equal each other?
Why?
Like, I don't know how to explain it, but if they're bisecting and cutting in half, then the other 2 have to equal each other.
Why? You're right, they bisect. It's got everything to do with the fact that those diagonals are bisecting each other. So if those 2 diagonals are cutting each other in half, what can you say about all the halves? They're all equal. So look at this triangle up here at the top. You've got, these 2 are equal, right? So what do you got? If you know this is equal to this because the diagonals bisected each other, then what do you have? Look at the triangle. What do you have?
Isosceles?
You have an isosceles triangle. What's the property of an isosceles triangle?
The two angles and 2 sides are
Congruent. So therefore you can say these 2 angles are congruent because the corresponding sides are congruent. So now that you know these angles bisect each other, you know that these halves are the same, so you have an isosceles triangle. Once you have the isosceles triangle, you've got the property of isosceles triangle. These 2 are congruent, therefore those 2 are congruent. Okay, so, and you said it a minute ago, you said about triangles, you said, well, we know this about triangles.
All the angles equal at 180.
Okay, and you know these 2 are the same, and you know this one, so can you figure out what these 2 are by deductive reasoning?
Yeah.
Okay, what are you going to do?
Subtract 110 from 180 again.
Okay, so 180 minus 110, which is 70.
And then divide that.
Divide by 2. If they're the same, that means they each have to be 35. Okay? All right. That's a difficult question, but that's nothing in there you didn't know. It's just a matter of thinking about it and figuring out, what do I know? What can I say? So to answer your question, Alexis, yes, the fact that they bisect each other is important. It's not a required property of rectangles when you're talking about rectangles, but it would be important to show something was true. Okay, so I've just given you 2 examples of where you would need to know that they bisect each other or that the diagonals cut the rectangle directly in half. We have a rectangle, the definition of rectangle, 2 sets of opposite parallel sides. Opposite sides are congruent, or you could say it's parallelogram and all angles measure 90 degrees. Now, so give me another, we're working in quadrilaterals, so give me another quadrilateral that needs a definition. We did quadrilaterals, parallelograms, rectangle, give me something else.
Rhombus.
Rhombus, okay, so, and I'm writing these down. When I talk to Alexis, I'm just going to put all the definitions out so that they're accurate and correct. Okay, so we have a rhombus, and when I put this up on the website, I'll probably break it into video 1, 2, 3, because otherwise it takes like 100 years to download if it's really long. Okay, so rhombus, so give me the definition of rhombus.
That was.
A complete definition. This, if I said, what's a rhombus?
So you can just say a parallelogram.
Okay, all right, good. A parallelogram, which we already, whoops, why is this doing this? Okay, I'm turning my back to you so the sound is facing that way. I'm not trying to be rude. A parallelogram. What is the extra definition of a rhombus that goes beyond just a parallelogram?
All sides are congruent.
With all sides congruent, right? Okay? Does that cover everything? Okay, give me another category of quadrilateral.
Kite.
Okay, kite. Now, can you start with parallelogram for a kite? No, a kite is not a parallelogram. So what do you want to start with? Quadrilateral, good, yes. You have to start with a bigger definition because you don't know it's not a parallelogram, so we're going to say quadrilateral. Quadrilateral. Okay, more? We've got it down to 4-side polygon. What else do you want to say?
Adjacent sides are congruent.
Adjacent sides are congruent. Is there anything else, or is that it?
Opposite angles are congruent.
Let's see, that's not true. Because think about it, if I drew a kite like this, are those opposite angles going to be congruent? No, this is going to be much bigger than the top one. So all you get out of a quadrilateral is that the adjacent sides are congruent. That's it. All right, you don't have any other information about that. Well, anyway, okay. Okay, so that's all you get from a kite, and that's why a kite is not a parallelogram, is because it has a very limited definition. Now it can, and that was the question on the test, it can become a rhombus, right? Because the rhombus says all 4 sides are congruent. Well, if you have 2 sides are adjacent, you've got 4 sides adjacent, you've got to cover the plus some. Okay, so that's why it worked with, so let me put 4 in here. All 4 sides are congruent. Okay, so we have a kite. Adjacent sides are congruent. What else? Now, what are the properties of a kite that's not part of the definition that might be helpful if I asked you a question? There's not a whole lot. What's another big property of a kite?
When they're the lines of something about the bisecting lines create 90-degree angles.
Yeah, the diagonals.
The diagonals.
The diagonals bisect. The diagonals don't bisect each other, but they create a 90-degree angle. Because if you looked at my previous one, if you've got a short, fat, and really long, the bottom is going to be a lot longer than the top. But yes, and that's also one of the properties of a rhombus, is it makes Now the rhombus not only makes 90-degree angles with the diagonals, but they do bisect, because it has the same properties of a square in that sense. But yeah, the 90-degree angles, remember, you guys, you got to find those right angles, because once you find the right angles, you open up the Pythagorean theorem as a potential way to find information. So one of the things you'll do on this test is hunt for the right angles, okay? Because that's going to be a big deal as far as that goes. Okay, so that was a kite. Give me another one, another quadrilateral.
Square.
A square, okay. What can you say about a square?
Would it be okay if we just said that, if we just shortened it and say a square is a rectangle?
Yes, absolutely. A square is a rectangle, which means it's a parallelogram with 90-degree angles, right? Okay, rectangle, what else?
And you would just say with all 4 sides congruent.
Okay, there you go.
That makes it easier.
Yes.
Short enough for the definition.
Absolutely, yeah. And then, or you could have said it's a rectangle that is also a What was the second part of that definition for the first one? Look at your first part of the definition for the rectangle. Rectangle with all 4 sides congruent. So it is a rectangle that is also a... Yes, there you go. Okay, yeah. right, does that make sense?
Yes.
Okay. So let's see, we have rectangle, rhombus, kite, square. What else? Is that, let's see, rectangle, rhombus, square. Okay, there's another, I think we've got one more quadrilateral. I think we're done with parallelograms, right? There's only 2 sets of parallelograms and they both mean the square. So what's left in the quadrilateral area?
The trapezoid.
Trapezoid, okay. So people are messing this one up too. Trapezoid, I think is right. Okay, so definition of a trapezoid.
Quadrilateral.
Quadrilateral. Whoops, what the heck? This thing is really touchy. Trapezoid. It is a quadrilateral.
With, exactly.
Good, exactly.
Of parallel.
One set of.
Parallel sides.
Are they congruent?
No.
No. As a matter of fact, if the parallel sides were congruent, would that automatically force the other set to be congruent? Can you think of a way to draw 2 lines that are parallel and congruent, even if you shifted them? That forces the distance between them to also, because if they're parallel lines, the distance will be the same at any point, right? And if they're congruent, you've just made the distance the same everywhere. So you just created a parallelogram. So they're only parallel, and they have exactly one side. The minute you say more than one set, it's quadrilateral, you go back in parallelogram. So the trapezoid is very... Now you have isosceles trapezoids, which means what?
The other 2 sides are congruent.
Congruent, right? Not parallel, but congruent, right? So an isosceles trapezoid would have one set of parallel sides and one set of congruent, non-parallel congruent sides, because they can be both parallel and congruent. Okay?